Welcome to Pure Production Flow, where today we uncover the incredible industrial journey behind the world's most famous golden French fries.
You have to try
Every
this one.
single day, millions of people enjoy these crispy treats,
perfectly
but few
salted.
understand the massive engineering feat required to produce them. To satisfy this global craving, a complex network of farms and high-tech factories must operate in perfect synchronization around the clock. Our journey begins right here at the source, in the vast, fertile fields where the perfect potato varieties are carefully cultivated. Not just any potato will do. Specific varieties like the Russet Burbank are chosen for their ideal shape and starch content. It takes months of careful monitoring, irrigation, and nutrient management to ensure these tubers reach the optimal size for processing. When the harvest season finally arrives, heavy machinery takes over, replacing manual labor to handle the immense volume of potatoes required. These advanced harvesters gently lift the potatoes from the earth, separating them from the soil without damaging their delicate outer skins. The machinery is designed to sift out loose dirt immediately, ensuring that only the crop makes it to the storage trucks. Synchronization is key here, as the harvester offloads tons of potatoes into waiting trucks without ever stopping its forward momentum. Once loaded, these trucks embark on a journey to the processing plant, where the raw earth bounty will transform into food. Upon arrival at the factory, the logistics team ensures a steady stream of raw materials enters the production line without delay. Gravity does the heavy lifting, as tons of potatoes are dumped onto the intake belts, ready for the rigorous cleaning process. The first step inside is the removal of foreign objects. Vibrating screens shake off loose soil and separate rocks from potatoes. A powerful water flume system gives the potatoes a thorough bath, washing away the field dirt and preparing them for peeling. Density differences are utilized here. Stones sink to the bottom of the trap, while the lighter potatoes float safely onward. Despite advanced automation, human oversight remains crucial at this stage to catch any large debris that might damage the equipment. Size matters for the perfect fry. The potatoes are sorted by diameter to ensure they are large enough to produce long strips. Only the best tubers make the cut. Those that are too small are diverted for other potato products like hash browns. The chosen potatoes enter a steam peeler, a high-pressure chamber that is about to subject them to a burst of intense heat. High-pressure steam is injected for a few seconds, loosening the skin from the flesh without cooking the potato inside. As the pressure is suddenly released, the moisture under the skin expands, effectively blasting the peel away from the potato flesh. Rotating brushes and water jets finish the job, scrubbing away the loosened peel and leaving the potatoes perfectly clean and smooth. The result is a stream of pristine white potatoes, stripped of their earthy exterior and ready to be transformed into fries. Another round of inspection ensures that any potatoes with green spots or significant blemishes are removed before the cutting stage. Now comes the most fascinating part of the process: the hydro-cutting system, which uses water as a powerful propellant force. Potatoes are pumped into a tube where a high-velocity stream of water accelerates them to speeds reaching 60 miles per hour. Waiting at the end of the tube is a stationary grid of razor-sharp blades, arranged to slice the potato instantly. The force of the water pushes the potato through the grid, transforming the whole tuber into uniform strips in a split second. This hydro-cutting method is far superior to mechanical chopping, as it causes less damage to the potato's cellular structure. Consistency is key, so the fries pass over vibrating screens that allow short pieces and slivers to fall through and be separated. Next, the fries enter the optical sorter, a marvel of technology where high-speed cameras scan every single fry in mid-air. The system is programmed to recognize defects like black spots or remaining skin, processing thousands of images per second. When a defect is detected, a precise jet of compressed air fires instantly, knocking the bad fry out of the production line. This automated quality control ensures that only the most perfect, blemish-free strips continue on to the cooking stages. Secondary mechanical sorters double-check the length, ensuring that the final product will have that iconic appearance customers expect.
Another set of mechanical
The raw
sorters
strips
aligns
now
the
enter the
fries.
blanching
This
tank,
ensures that
a
the
crucial
length
step
distribution
involving
meets the
hot
strict
water that serves
specifications of the
multiple
brand.
chemical purposes. Blanching leaches out excess natural sugars from the potato, which prevents the fries from turning dark brown or burning
As the sugar
during frying.
molecules leave the
It
potato
also
strips and
deactivates
diffuse into the
enzymes
water,
that could cause
it prevents the
spoilage
fries
and
from
creates a
burning
more
or
uniform
turning brown
texture
too
throughout
quickly.
the entire batch of fries. To ensure that perfect golden color, a precise solution of dextrose is showered over the fries to
Dosing
replace
pumps,
some surface
adding a
sugars.
precise amount of dextrose
Sodium
solution
acid
to the fries.
pyrophosphate is also
This
added,
coating
a
ensures
safe
they brown
additive that
evenly
prevents the
later.
fries from turning gray after they are cooked. Before they can be fried, the strips must be dried. Excess water would lower the oil temperature and degrade the texture. Warm air circulates through the drying tunnel, removing surface moisture and preparing the potato exterior for a crisp finish. The fries emerge firm and dry. This step is vital to prevent the oil from splattering and ensures efficient heat transfer. Now they enter the par frying stage. They are not fully cooked yet, but partially fried to set the crisp texture. This short frying session sets the outer shell, giving the fry its structural integrity while leaving the inside soft and fluffy. The oil temperature is strictly controlled by computers to ensure that every batch receives exactly the same amount of heat energy. After a precise amount of time, the fries are lifted from the oil. They are now par fries, ready for freezing. Excess oil is shaken off immediately. We want the fries to be crispy, not greasy, so drainage is an important step. The hot fries travel directly into a blast freezing tunnel, where the temperature drops dramatically in a matter of seconds. Rapid freezing is essential to preserve the texture. It prevents large ice crystals from forming, which would make the fries mushy. Emerging from the tunnel, the fries are now frozen solid, locking in their freshness until they reach the restaurant fryer. A final sort takes place to catch any strips that might have broken or clumped together during the freezing process. Precision weighers divide the massive stream of product into exact portions, ready to be dropped into the packaging bags. Automated bagging machines work at incredible speeds, forming, filling, and sealing the bags in a blur of synchronized motion. Quality assurance continues until the very end, with check weighers verifying that every bag meets the promised net weight. Safety is paramount, so every single bag passes through a metal detector to ensure absolutely no foreign objects are present. Robotic arms take over the packing duties, gently placing the bags into cardboard cases with tireless precision and efficiency. The cases are sealed and labeled with tracking codes, allowing the factory to trace every batch back to its origin farm. Heavy-duty robots stack the cases onto pallets, building stable structures ready for transport and storage in the warehouse. Forklifts whisk the pallets away to a massive cold storage facility, where they await distribution to restaurants around the world. This cold chain must be unbroken. The fries stay frozen from this moment until they are dropped into the fryer at McDonald's. Refrigerated trucks arrive daily to collect the product, acting as the rolling link between the factory and the consumer. From here, the fries embark on their final journey, traveling hundreds or thousands of miles to reach your local restaurant. At the restaurant, the staff carefully stores the boxes and freezers, ensuring the fries remain frozen until the moment of cooking. When an order comes in, the frozen fries are poured into the basket. Notice how they remain separate and do not clump.
Need to get these frozen
The
fast.
final cooking stage begins. The hot oil finishes the job started at the factory, crisping the exterior and warming the interior. In just a few minutes, the fries transform into the golden, crispy, and aromatic product that is famous worldwide. Timing is everything. The fries are lifted at the perfect moment, shaken dry, and poured into the holding station. A precise amount of salt is sprinkled over the hot fries, enhancing the natural potato flavor that has been carefully preserved. With a practiced motion, the fries are scooped into the iconic red sleeve, standing tall and ready to be served. The journey is complete. From a raw tuber in the dirt to a hot, crispy delight, Science and engineering made this possible. Let's take a moment to appreciate the sheer complexity of the process we just witnessed. A symphony of agriculture and technology. The transformation is drastic. It requires precise control over temperature, time, and mechanics to turn nature's produce into a standardized product. The factory never sleeps. These machines are marvels of modern engineering, designed to operate continuously with minimal downtime or error. Sustainability is also part of the equation. Waste products like peels and starch are often repurposed for animal feed or energy. Water usage is massive, so advanced filtration systems recycle the water, allowing it to be reused for cleaning and transport. Behind the machines are teams of skilled engineers and technicians who ensure that this complex mechanical ballet continues without interruption. In the lab, food scientists constantly test samples, measuring texture, solid content, and color to maintain the brand's high standards. They even measure the crunch factor mechanically, ensuring that the fries will provide that satisfying snap when you bite into them. But ultimately, technology relies on nature. The cycle begins and ends with the land, the weather, and the farming communities. The partnership between growers and processors is vital. Decades of collaboration have optimized the potato specifically for this industrial purpose. Selective breeding has created potatoes that are longer, have fewer eyes, and contain the perfect balance of starch and water. The speed is relentless. A single factory can process hundreds of tons of potatoes every day to keep up with demand. Innovation continues to drive the industry forward, with smarter robots and AI systems constantly improving efficiency and reducing waste. We have come a long way from hand peeling and manual chopping. Automation has democratized access to this once labor-intensive side dish. While you sleep, these factories hum with activity, preparing the food that will be served for lunch across the globe tomorrow. The consistency achieved is remarkable. A fry eaten in New York tastes almost identical to one eaten in Tokyo or London. Beyond the cold steel and industrial processes, the end result is a simple moment of joy for people of all ages. Let's revisit the steam peeling for a second. That split-second explosion is a perfect example of using physics to solve culinary problems. And the water gun cutter remains the hero of the line, a brilliant invention that revolutionized the entire French fry industry. Each strip is a piece of agricultural engineering, shaped by nature and refined by science to be the perfect vessel for flavor. The quality of the oil is just as important as the potato. It is constantly filtered and monitored to prevent off flavors. Modern factories also manage their environmental footprint, scrubbing exhaust air to minimize odors and emissions released into the surrounding community. The sheer volume is hard to comprehend. Miles of conveyor belts transport these potatoes through their transformation every single hour. Hygiene is non-negotiable. Regular deep cleaning cycles ensure that the production line remains sterile and safe for food production. Thousands of sensors act as the nervous system of the factory, constantly feeding data to the central control room for adjustments. From the control room, operators oversee the entire process, ready to intervene at the slightest sign of deviation from the standard.
The pressure is fluctuating beyond
The cycle
tolerance.
actually begins years before, with the careful selection and propagation of seed potatoes to ensure genetic consistency.
All right, thanks.
Agronomists work closely with farmers, analyzing soil composition to provide the potatoes with exactly the nutrients they need to thrive. Water management on the farm is crucial. Precision irrigation ensures the crop gets enough moisture without wasting precious water resources. After harvest, potatoes are stored in climate-controlled dark sheds. This curing process heals minor skin damage and converts sugars to starch. Managing sugar levels during storage is a science in itself. If the potato gets too cold, sugar spikes. Too warm, it rots. Thanks to these advanced storage techniques, factories can produce fresh fries year-round, even months after the harvest has finished. Back in the factory, the energy is intense. It is a loud, hot, and humid environment where raw power meets precision. The blades in the hydro cutter are replaced regularly. Even a microscopic doling of the edge can shatter the potato instead of slicing it. Responsible manufacturing means treating the water used. Solids are settled out, and the water is purified before returning to nature. Energy efficiency is maximized by capturing waste heat from the fryers and using it to warm the water for the blanching process. The packaging material itself is engineered for protection, designed to prevent freezer burn and keep the fries separated during transport. Even the cardboard boxes are tested for crush resistance, ensuring they can protect the fragile frozen product at the bottom of a stack. For international markets, these frozen treats travel in refrigerated containers on massive ships, crossing oceans to reach your plate. It is truly a global food. No matter the culture or country, the love for a hot, salty French fry is universal. We must not forget the human element. Hundreds of dedicated workers operate these lines, taking pride in feeding the world. The perfect fry is a study in contrasts, a crispy golden exterior protecting a fluffy, steaming interior of cooked potato. Whether dipped in ketchup, mayonnaise, or eaten plain, the engineering ensures the texture holds up to the very last bite. From the quiet patience of the farm to the high-speed roar of the factory, this is a masterpiece of modern logistics. It demonstrates how technology can scale up a simple cooking process to feed millions without sacrificing quality or safety. So the next time you order a side of fries, take a moment to appreciate the incredible journey they have made. They are more than just a snack. They are the result of agricultural science, mechanical engineering, and global cooperation combined. Thank you for watching this episode of Pure Production Flow. Subscribe to our channel to discover more mesmerizing industrial journeys.